Hey everyone.
So in today's session, I'll be starting with the first module, which talks about Linux fundamentals. And let us see what is the agenda for today's session. So the main objective of this particular module would be understanding the history of Linux, how one can differentiate between Linux and Unix. I'll tell you about the architecture of Linux operating system, and then one should have a clear understanding how you're gonna select Linux distribution. As we all know, we have wide variety of Linux distributions or Linux flavors available today in the market. Let's talk about Facebook. Facebook for social stability and support. We know some of the biggest websites in the world depend on Linux, and the mighty Facebook is a part of that particular group. According to Amir Michael, who works as a former hardware design manager at Facebook, the social networking platform, which is built on lightly modified version of CentOS, with the certified support from Red Hat. I think most of the people worries about what is CentOS, what would be the difference between CentOS and Red Hat. I'll just clarify this particular concept in the further slides. So according to him, this particular Facebook platform, the website which was designed, is designed on lightly modified version of CentOS, Community Enterprise Operating System, with a certified support from Red Hat. A very ideal combination in this line of work. Like CentOS provides the stability company like Facebook needs to deliver a consistent user experience, while Red Hat comes through in the clutch with proprietary software packages and enterprise support you just can't get from the community. If I can provide you in single line, the major difference between CentOS and Red Hat. Now, CentOS comes under non-commercial stream and Red Hat comes under commercial stream. That means everyone knows that Linux is open source, Linux is freely available. But if you talk about some commercial products, product is anyways available free of cost, but for support, for getting updates, you just need to pay some fees to some corporations. Like Red Hat comes under commercial stream, but CentOS comes under non-commercial stream. CentOS is just replica copy of Red Hat, but CentOS doesn't have any enterprise support, nothing like that. But Red Hat Enterprise Linux has the enterprise version of Linux operating system. So you see, Facebook, which is considered to be one of the big social networking platform, is built on Linux platform. Same like if you take other companies like DreamWorks. So Linux has become a star in Hollywood. One of the most famous Tinseltown examples comes from DreamWorks, the production powerhouse behind hit films such as Madagascar, Kung Fu Panda, and Shrek, the animation sensation that made the company a monster. So this particular firm leverages Linux processing power to support the robust rendering farm that produces most of the rich graphical magic we can see on the big screen. According to Red Hat, nearly every artist at DreamWorks uses Linux on their desktop computers. Not only desktop, even server-based operating system is powered through a Linux operating system. So not only Facebook, not only DreamWorks, even Google. The fantastic thing about open source software is that you are generally allowed to take a piece of code and you can use it to build your own product. I think we should thank to Richard Stallman, who started Free Software Foundation, FSF. This is what you can do. Anyways, Linux kernel, some 300 million lines of code has written. Even you can download this particular source code. You can inject your own features. You can put your own application drivers, whatever you want, and you can have your own product. So this is what Google has done. Google has developed its own Linux distribution called Gubuntu, a slightly modified version of Ubuntu, the most popular desktop distribution. Like that, you got so many examples, like why major companies, most of the major companies, enterprise companies, they're powering up their platform using a Linux operating system. You take one more example, Munich for system liberation. With so much of critical information on their systems, the government of the world can't afford to compromise reliability in computing. So Linux is an ideal solution for them with a secure architecture, cost effectiveness, and flexibility that allows different offices to seamlessly share information. So they have done this along like 10-year project. The city of Munich recently completed a 10-year project when migrating nearly 15,000 desktops to Linux, a custom distribution the city authority came up with themselves. This is from local German government. They have developed their own distribution of Linux operating system called Linux. So like that, the entire world, I would say even NASA, they power their supercomputers using a Linux as an operating system. So let's talk about what is Linux, what is the importance of Linux. As I told you, Linux is just an open source operating system which is modeled on Unix flavor and developed in C language. One must be wondering like what is Linux, what is Unix, what are the differences between Linux and Unix operating system? Why this came into picture? What is the difference between like open source software, closed source software? Why Linux came into existence? So what is Linux? Linux is just a open source operating system. I would say it is just a copy of Unix, which was completely written in C language. According to my readings, like open source software is a software with a source code that anyone can inspect, anyone can modify, anyone can enhance the code. From developers' point of view, if you talk about open source, like if you talk about source code is just the part of the software that most computer users don't ever see. It's a code for computer programs can manipulate to change how a piece of software or a program or an application works. Programmers, developers, as we know, who have access to the computer program source code can improve that program by adding features, fixing the bugs that don't always work correctly. So one should have a clear understanding about the differences between the open source and other types of softwares. See, according to the industry, like some software has source code that only the person, team, or organization who created it maintains exclusively control over it. People call this kind of software as proprietary, but according to me, I can just call them as a closed source software. That means only the original authors of proprietary software can legally copy, legally inspect, and modify that software, not public users. Who owns that particular source code? Who owns that particular software? Only those people can copy, inspect, and modify that particular software. But open source is completely different. Yes, its authors makes it source code available to others who would like to view the code, who would like to copy the code, who would like to learn from it, who would like to modify it, or who would like to share it. If I just take a small example like Microsoft Office, even the operating system is not free of cost. Even applications which are runs on the Microsoft platform are not free of cost. Every application, every program is proprietary in Microsoft platform. But in Linux, it's not only kernel, it's not only operating system. On top of that, whatever applications you see on Linux platform, everything is available free of cost. That means no license required, no need to pay anything. That is the difference between the open source software and closed software. If you talk about closed software, Microsoft Office, Adobe Photoshop are the classic examples of proprietary software. When you talk about Linux, in Linux you have LibreOffice, you have GNU image manipulation program, which is equivalent to Adobe Photoshop. So these are the examples of open source software, which are available completely free of cost. So this is what I was talking about. What is exactly open source and how open source founded? Richard Stallman. I think we should thank to Richard Stallman who started the movement called FSF, Free Software Foundation. Under this Free Software Foundation, he has introduced many licenses. GNU GPL version 2, GNU GPL version 3. You also have Apache license. You also have MIT license. So any product, any application which are available under these licenses are free of cost. Let me give you a brief history of a Linux operating system, how Linux has been evolved, what made Linus Torvalds to create a Linux kernel. As we all know, in the years of 1960s and 1970s, Unix was a proprietary operating system. Unix is patented, Unix is copyright, and Unix supposed to work on specified platforms. In those days, Unix was confined to only specific platforms. It is not supported on all the platforms. In the year 1969 and 1970, when Unix was developed, implemented, and released by Ken Thompson and Dennis Ritchie, who's the father of C language. So these people, they worked on a project called Multics, and slowly the project name has been changed to Unix, UNICS. It is not UNIX, it is UNICX. Multics project has been renamed to Unix. And in the year 1977, BSD, Berkeley Software Distribution, contained Unix code that was developed by University of California at Berkeley. In the year 1983 and 1986, Richard Stallman came into picture and he started a free software foundation under the license called GNU and GPL. GNU is a recursive term, GNU not Unix. GPL stands for General Public License. So Unix-like operating system, it is not exactly Unix. You just copy the lines of code from Unix, and he created a Unix-like operating system which was called as Minix, MINIX, which was free, available for copying, available for modification. And then in the year 1991, I'll tell you how Linux came into existence, who invented Linux. So Linux is germinated as an idea in the mind of a young and bright student who was called Linus Torvalds. When he was a computer science student, he used to work on Unix operating system, which was proprietary software those days, and thought that it needed some improvements. However, when his suggestions were rejected by the designers of Unix, especially Ken Thompson and Dennis Ritchie, he thought of launching an operating system which will be receptive to changes, modifications suggested by its users. So what he has done, Linus Torvalds, he devised a kernel named Linux in the year 1991. However, he would still need programs like file manager, document editors, audio video programs to run on it. As time passed by, he collaborated with other programmers in the places like MIT, and applications for Linux began to materialize. So around 1991, a working Linux operating system with applications was officially released, officially launched. This was the start of one of the most loved and open source options available today. The earlier versions of Linux were not so user-friendly as they were in use by computer programmers, and Linus Torvalds never had it in mind to make it commercialize the product. So this definitely curbed Linux popularity, while another commercially oriented operating systems like Windows and Mac, they're in famous world. Nonetheless, the open source aspect of the Linux operating system made it more robust and accessible nowadays. So this just was a brief history how this came into existence. It's all because of Linus Torvalds, who was a student in University of Helsinki in Finland, because his suggestions were rejected and he thought of creating a Unix-like operating system, but not exactly Unix. He has just copied some millions of lines of code and he created a Linux kernel. It's officially launched in the year 1991. So if you want me to categorize the differences between Linux and Unix, this is what you see. You see the parameters in terms of cost, in terms of flexibility, source code, installation, community support, bug fixes. You can see the differences between Linux and Unix operating systems. Again, in Unix also, there are many flavors available. As we all aware, we have IBM AIX, we have HP UX, and we have Solaris 2. IBM AIX, this is one of the flavor of Unix operating system which confined only to IBM platforms. Now you can't take IBM AIX to install on your desktop computers, to install on your laptops. It's not compatible with your hardware. They specifically need IBM servers, IBM P series, IBM Z series, IBM E series. Only on respective platform you should be able to work with AIX. Similarly, goes with HP UX. It specifically works on HP platforms. Solaris on Spark platforms. Now they've made it available for all the platforms. They've introduced Open Solaris. Now Solaris, I think you should be able to install on Intel processors, on Spark processors. You should be able to do that. I think recently, 7 or 10 years back, they have released, even they've made it open source, Open Solaris. So you can see in terms of cost, flexibility, source code installation, see the differences between Linux and Unix. Unix is not available free of cost. Unix is patented. Unix is copyrighted. It's not free. Different vendors have different prices. Oracle has different strategy. IBM has got different strategy. HP has got different strategy. But Linux is not like that. Linux is proprietary free. Linux is available open source. Even you should be able to download the source code. You can modify. You can have your own version of Linux distribution. See, that much freedom has been given to Linux, which is not available in other platforms. Flexibility, yes. No flexibility in Unix and other platforms there. Source code is available free of cost. Installation, economical, but Unix flavors only on specialized hardware. Community, since it is available open source, I think thousands of millions of users has got support to Linux community. Since it is made open source, I think each and every developer has got support for this operating system. Support, bug fixes, you can't even compare with Linux. So this is the technical differences between a Linux and the Unix operating systems. The features of Linux operating system. So why it has gained a lot of popularity over the years? Because of this particular features. Linux is open source, significantly reduces the monitoring cost, huge base of developers that freely provide support. It is reliable as it runs smoothly and no need to reboot it repeatedly. Every day, I just run into issues on my laptop. I got Windows 10 on my machine, on my laptop. I'm not quite sure what is exactly happening with the operating system because in Windows, we are just working with the color TV. We don't know what is exactly going in the backend. If it is stuck, if it is hung, the only way to bring back my system up and running is only to reboot the system. Because in Windows, we are not working with the operating system, we are just working with color TV. That's it. But in case of Linux, you will be knowing each and everything what is happening inside the operating system. There are different ways of accessing Linux computer. In real time, I did not see a system administrator. I did not see any particular person accessing Linux computer or Linux server in graphical mode. All the way, you can see a text-based terminal, something like this. Right click, you just open a terminal here and start interacting with the operating system like this. You only see a black and white TV, something like that, executing all the commands, something like this. Because in Linux, what exactly happening is you're closely working with the operating system. Since you're working in command mode, you would be knowing each and everything what is exactly happening inside the operating system. So the trust, the freedom is given to the users. So licensing freedom, since it's open source, no copyrights, no patents, can be customized. I told you, you can go to kernels.org, the official website of Linux kernel. You can go to kernels.org. You can download the Linux source code. If you are very good at programming, you can have your own version of Linux operating system. You can inject your features. You can put whatever features you would like to have in that distribution. That is the only reason in Linux we have almost 600 plus distributions like Red Hat, Ubuntu, Debian, Slackware, Kali, Buffalo Linux, Mint. Like that, there are many distributions available. In every distribution, definitely you would be having certain advantages and disadvantages. That differences you can find, definitely. Yes, it's flexible, can be customizable, which is not possible in other platforms like Unix or Windows or Mac. So I think you all agree to the fact that Linux is being considered as one of the most secure operating systems. Yes, it's been considered as one of the most secure operating systems on the planet. Since Linux is not only open source, on top of that, every application, every tool you will be getting free of cost. You won't remember, like in Linux there are like two ways of secure the systems. One with TCP wrappers, one with firewalls. You can put two lines of security. You can defend your applications, you can defend your services in two lines of security. Even if the first line is compromised, even you should be able to control your traffic in the second line. That much secure. Built-in firewall, built-in all tools are available free of cost. So where exactly Linux is used? It is not only a desktop operating system, it is not only a server-based operating system. Even I can convert a Linux box into a powerful router with just two interfaces. I can just take two LAN interfaces, and within that two LAN interfaces, I can enable routing, and I can do different kinds of routings also. Static routing, dynamic routing. So Linux can be used in different ways. Linux can be used as desktop, Linux can be used as server-based operating system, Linux can be used in supercomputers, it can be used in wide variety of ways. That is the beauty of using Linux operating system. And coming to the components of Linux operating system, if one has got good knowledge about the booting process, how it boots and what are the components involved in booting Linux computer, you would see these all the components here. The first component what you see is init program, and this has been changed. I think the latest version of, especially when you work on Red Hat, when you work on CentOS, the latest version is 8. Earlier versions were 5, 6, 7. Even the certification is based on 8, RHEL 8, Red Hat Enterprise Linux version 8. You know, whenever you power up a Linux computer, I think systemd is the very first program which starts, and after starting systemd, it will trigger other services to start. What is the first program starts when you boot a Linux server? In case of RHEL 6 and RHEL 5, it was init program. Init was replaced with systemd. There is a slight difference between RHEL 6 and RHEL 7 and 8. Till RHEL 6, init was the first program. From RHEL 7, systemd is the very first program which does initialization of services. Systemd. Bootloader. As we all know, bootloader is one of the important components which is very, very useful at the time of starting the system. Bootloader is a program which loads the operating system from the hard disk to memory. If you don't have a bootloader, it is highly impossible to start a Linux computer. If you take a small example of Windows, Windows has got the default bootloader called ntldr.exe. Sometimes when you power up a Windows machine, if Windows machine is not loading up, if it is not loading from hard disk, you would generally see an error message, ntldr.exe is missing. You work with Windows 10, you work with server-based operating system, the default bootloader for Windows operating system is ntldr.exe. Likewise in Linux, grub. Grub is the default bootloader for loading Linux operating system from disk to RAM. So in the latest releases of Linux operating system, it is grub 2. The enhanced version of grub is called grub 2. Like that, you have software libraries. Whatever program you execute in the backend, some libraries has to call, some system calls will happening. How to read the file from the hard disk, how to fetch the file from the hard disk. So you got some system calls, right? So that system calls can be happen with the help of libraries. Unlike in Windows, we call them as .dll files. DLL is nothing but dynamic link libraries. Like in Linux and Unix operating systems, those are called system libraries, software libraries. Okay, software libraries are very much used in order to work with any programs and applications. You don't have a library to read a file, you don't have a library to write a file or to fetch a file, definitely that application will stop functioning. Like that, you have a package management system. The package management system is useful for installing, updating, removing certain packages on the operating system. Till RHEL 5, RPM was the default package manager, Red Hat package manager. But after RHEL 5, from RHEL 6, Yum is considered as a default package manager from RHEL 6 onwards. Like every flavor has got their own package managers. When you're working on Ubuntu and Debian, you would see DPKG or APT. When someone working on SLIS, SUSE Linux Enterprise Server, you would see something called YAST2, yet another setup tool, something like that. Every distribution has got their own package managers. That is what I'm telling you. Linux OS is free. You should be able to download the code. You can inject your own features. You can have your own product. Like what this Red Hat people has done. Red Hat people has downloaded Linux kernel. They have injected all their features the way they want to work with the operating system. They want to work with the applications. Like every distribution has got their own applications and programs. So next we'll talk about the architecture of Linux operating system, how it works and what is the idea behind it. In fact, this is all the same with every OS, but the difference in the way they're accessing the OS. So you see, the architecture of Linux operating system has been divided into like 4 layers. The architecture of Linux system consists of the following layers. The first layer, what we call is hardware layer. The hardware layer consists of all peripheral devices like RAM, hard disk, CPU. Now, what are all the devices attached to your system? All devices will work under this particular layer. And the next layer, upon that you can see kernel. It is one of the most core component of operating system which interacts directly with the hardware and provides low level services to upper layer components. Kernel. The kernel is nothing but core program, a core component of an operating system. Now, kernel has got the leverages to directly interact with hardware, and it can provide some low level services to upper layer components. And then after that, you have a shell, and I would say shell is nothing but an interface to kernel. How do you interact with your operating system? You need to have some kind of interface. That interface is exactly called as shell. Shell is nothing but interface to kernel, which hides all the complexities of kernel functions from users. What exactly happens in real time, I'll tell you, like when you execute any particular command. So just now we executed a command on Linux shell here. If you see, this is my testing box over here. I've just executed a command called echo edureka. So this is exactly called as user interface. This is exactly called as shell. So this is just like an interface given for all the users who would be able to interact with Linux kernel. So what exactly happens if I execute any particular command? What shell does is, shell takes the commands from the user and it executes what? Kernel functions. Since I would like to print edureka onto my screen, I executed a command called echo and the message I want to print on my screen. So what is shell doing? Shell is accepting all my commands and executing the kernel functions. And on top of that shell, you have all the applications and programs. Utility programs that provides the user most of the functionalities of an operating system. Now, in layman terms, if I want me to explain about the architecture of Linux operating system to kind of explain what Linux is, you have to explain what is an operating system is. The thing about the operating system is that you are never ever supposed to see it because nobody really uses an operating system. Frankly speaking, nobody really uses an operating system. What we bothered about, like people use programs on their computers. The only mission in life of an operating system is to help those programs to run. So an operating system never does anything on its own. It's only waiting for the programs to run, ask for certain resources, ask for certain file on the disk, or ask for programs to connect to outside world. Then the operating system kicks in and makes it very easy for the people to write programs. So this is what I was talking about. Hardware, CPU, RAM, hard disk drive, kernel. See, what are the functions of kernel? Resource allocation, security management, process management, device management, scheduling, memory management. All these tasks performed by the kernel. And then again, if you talk about the kernel, you have different types of kernel again. You have something called monolithic kernel, microkernel, and hybrid kernels. That's all advanced part. You see the functions of kernel. And then I was talking about the shell, right? Shell is the interface which takes the user command and sends it to the kernel. So again, if you talk about the shells, again we have different types. We have different types of shells. Now, when you're working with many flavors, you work with Ubuntu, you work with CentOS, Red Hat, Bash has been incorporated as a default shell. Why Bash? Why not other shells? Why not C shell? Why not Corn shell? Why not Turbo C shell? You can see some examples over here. How shell works? As I told you, as a user, you would like to execute a command or you would like to execute some shell script. So Linux shell will accept all the commands from the user. And what the shell does is, shell will be converting all your inputs into the binary, the computer, a machine understandable language. And then it will send to kernel. So directly, indirectly, so what is shell doing here? Shell is executing kernel functions. So most people often get confused that shell is exactly a compiler. No, it is not a compiler. It is exactly called as an interpreter. So shell is an interpreter. It is not a compiler. So shell takes the command in human readable format and provides it to the kernel in binary language, machine understandable language. So as a user, if I want to interact with the operating system, generally, I should be able to interact with the operating system only through shell. See, directly, it is not possible for us to interact with the hardware. So do we all know machine understandable language? Do we know zeros and ones? Definitely we don't know about machines language. So I should be able to interact with operating system only with the help of shell. So that is what I was talking about. Different types of shells. You have bash shell, you have C shell, you have corn shell, you have turbo C shell. There are a lot of shells available. And when you're working on major distributions of Linux operating system, bash is considered as a default shell. Even if you want to ensure, let me just open a small command window here. I've already have my Ubuntu box up and ready in the practical lab. I can ensure what is my default shell here. I'm just calling an environment variable with the echo command to find out what is the default shell in my operating system. You can see the default shell is /bin and bash. /bin is the location where this particular program exists. You can see the complete absolute path /bin/bash. You can also check with a command called which. You would see where exactly this program exists. There is also one configuration file here to see what are all the shells supported by this operating system. You can read this configuration file by executing the command cat. Now, cat is a basic command in Linux to create files, to view the file contents and everything. You can see here, you have shell, you have dash, you have bash, rbash, so many shells. I think corn shell, C shells have not installed here. Once after installing those particular applications, you would also see other types of shells. So what would be the differences generally? Why we have this many shells? What is the difference between bash, C shell, corn shell, turbo C shell? So I would say in simple words, like bash has got many advantages over other shells. Like I would say, like it supports command completion, it supports command history, and it also supports command aliasing, where we don't have this kind of features in other shells. Bash is user friendly, it's flexible, it's part of GNU project. When you work with C shell, when you work with Conch shell, those are not user friendly shells. As a user, if I want to execute a command, I can simply recall the command by using up and down arrow keys. This is not possible in C shell or Conch shell. Again, we need to type the command. So if you see a small example, if I want to clear my screen, I should execute a Linux command called clear, which clears my screen. Whatever you do, for example, whatever you do, you want to clear your screen, you need to execute the command called clear, or you have a keyboard, you have a bash shortcut, the bash shortcut called Control L, which clears the screen. You can type clear command, or there is a shortcut called Control L. You don't find all this in other shells like C shell or Conch shell. Or what you can do, if you don't want to type this lengthy command, even you should be able to alias this particular command. I can put alias C is equal to clear. That means rather than executing clear command, I can simply type C and press enter, because I created alias for the command clear. All this benefits, all these advantages you can see in bash. That is the only reason in major distributions of Linux operating system, bash is the default shell. You can check that. If you want to shell, what is the default shell? You can call this system environment variable. This variable I didn't create. This is inbuilt with the operating system. To check and find out what is the default shell in this particular operating system. See, I think for labs also they are using Ubuntu 16.04 version, light threaded server. You work with CentOS, you work with Red Hat, you work with Debian. So this is being considered as a default shell. So this is what I was talking about. Bash shell, C shell, Corn shell, Turbo C shell, all this you can see. So these are the Linux distribution. Told you, right? We have almost 600 plus distributions in Linux. The most popular ones would be Ubuntu, Debian, Red Hat Linux, Fedora, all this you can see. Every distribution has got their own advantages and disadvantages. Every distribution has got their own features, own advantages. Based on that, you should be able to select. I think Ubuntu stands first according to the usage, according to the popularity. Ubuntu stands first. In Ubuntu also we have different version. You got desktop version, you got server based version, you got powerful graphical server versions, you got a lot of versions from Ubuntu, and it is owned by the company called Canonical. Simple, you can go to Ubuntu, freely downloadable, whatever versions you would like to download. Ubuntu.com, you see there are different versions of Ubuntu's systems available. The latest version you see here, Ubuntu 20.04 LTS. From older versions, you see different versions are available here. Cloud, IoT, Raspberry version, server, desktop versions. You see Ubuntu flavors. You see K Ubuntu, L Ubuntu, Ubuntu Budgie, Kylin, Mate, Ubuntu Studio. This is mostly for graphics, multimedia. X Ubuntu, different flavors in Ubuntu also. There is no difference in executing the commands. Like I would say, one technical difference, you see what difference you might see between all this. So if people working on Red Hat, see most of the companies, most of the firms, they use Red Hat. They use RHEL, Red Hat Enterprise Linux. This is a commercial stream. Under non-commercial streams, they have CentOS, Community Enterprise Linux, and even they have Fedora. This all comes under non-commercial stream. That is the enterprise version. These are non-enterprise versions. Like that, you have Ubuntu. Like that, you have Debian, you have Sklees, you have Mint, you have Kali Linux. Like that, you have many flavors available. Now, majorly, I work on Red Hat, Ubuntu, and Sklees. In Red Hat, if anyone wanted to do a package installation, for example, if anyone wanted to install programs, install applications, the package manager would be RPM or yum. In the latest release of Linux operating system, it is DNF now, dandified yum, especially in RHEL 8. When someone working on Ubuntu and Debian, in Ubuntu, they have their own package manager. If you try to install this with yum here, it doesn't work. You have to get with APT, Advanced Packaging Tool, or DPKG, Debian Package Manager. Likewise, when someone is working on Sklees, they have their own package manager. They call it as YAST. The latest version is YAST 2, yet another setup tool. Like that, they have their own features, own enhancements, something like that. But command-wise, execution-wise, implementation-wise, it's all the same. Like if anyone wanted to implement web services, here it is called the package called HTTPD. In Ubuntu, it is called Apache 2. That's a difference you can find. Not that technical differences, that's a differences you can find. How to choose a distro? Based on number of factors, purpose of usage, installation, look and feel, video games, graphical interface or command line interface, how easy you should be able to install this operating system. Configuration is done with default values or it's manually chosen. Personal or professional usage. I think for this training, what we are recommending, what we are preferring is Ubuntu. Even if you wanted to work with CentOS or RHEL based distribution, you should good to go with that. The labs, what we are providing, the labs also, it's completely based on Ubuntu flavor. See, Ubuntu, it's one of the most popular Linux distributions, secure and reliable, multi-variant releases. You got desktop, you got server, you got graphical servers, you got different flavors of Ubuntu also, frequent releases, easy to use. It contains a wide range of software like LibreOffice. Like in Windows, we used to have Microsoft Office. So like that, we have LibreOffice. I think in Windows, we have a default web browser, Outlook mail application. Here we have something called Thunderbird, which is similar to Outlook. And also games such as Sudoku, chess. Like that, you have Fedora, you have Debian, you have Red Hat. As I told you, Fedora comes under non-commercial stream. According to my reading, now this Red Hat, I think every 12 to 18 month cycle, there would be a new release, new commercial release. That means currently, I think you're working with the latest version RHEL 8. After 12 to 18 month cycle, you would be seeing the new version. Like that, you have Fedora. This is an unstable version. This is not a stable version. Fedora, every 3 to 6 month cycle, or I would say 6 to 8 month cycle, there would be a non-commercial release. 6 to 8 month cycle, every 6 to 8 month cycle there would be a non-commercial release. I think today you're working with Fedora 31, for example. After 8 months, you would be working with Fedora 32. So this is not a stable release. This is unstable release, and this is a stable release. Here, no support would be provided. No support would be provided. Here, you can expect the enterprise support from Red Hat. And if you want me to give you some more information, like here, no need to pay anything, no fees, but only for support. According to my experience, I think $329 per annum. Only for support, not for operating system. Anyways, operating system is free of cost. I'm talking for commercial releases. I think this is way back 2 years. I don't know what is the strategy now, what is the cost now. I think they have increased it. $329 per annum only for support. You're not paying for operating system, only for support you're paying. Like that, you would see the differences between the commercial stream and non-commercial stream. So now we'll talk about some concepts in Linux here, some miscellaneous Linux concept. We'll discuss what is exactly a file, what is run level, and what is a pipe here. Since I told you in Linux, everything is considered as a file. You work with the device driver, you work with any program, you work with any particular library file, everything is considered as a file. Whatever you would like to do, whether you would like to access a device, CD-ROM drive or hard disk drive, everything is considered as a file. So in Linux, there are many such file types. How to differentiate file types? How to differentiate between a text file, a device driver, or executable program? So you have some methods to find out the differences here. That is, I'm going to show you practically. For example, you would like to find out what would be the CPU configuration on your system. For example, you would like to find out some hardware information about your system. In general, in Windows, we go to some device properties, we'll go to some hardware configuration. We can see what are all devices attached to our Linux box, like Windows box. In Windows, you have something called device manager. You go to system properties, device manager, and you should be able to check all the device info. But in Linux, everything is just like a file. For example, you would like to check what is the CPU info here. You run the command called cat and /proc/CPU info. Just like a simple plain text file here. Once you press enter, you would be able to see the configuration of your CPU. What is the CPU type? How many cores it has? What is internal cache memory? All that information you should be able to find out. That means CPU info is just like a device file. For example, you want to find out the information about your hard disk. I keep using the command Control L, which is used for clearing the screen. Like rather than executing the clear command, I keep executing the shortcut called Control L. Now, in the case if you want to see the information about your devices here, you can find out. I think I don't have SATA hard drive here. Let me find out. I think I'm not the privileged user to execute all the such commands over here. Layer 934, you're not able to execute that. No such file. I'm not sure what device has been attached over here unless I gain super user access. I'm not sure what is the password for this. I just need to check with the support. So like that, you can check the different types of files and everything over here by just executing the command called ls-l. So normally if you just type in ls, you should be able to see your files. But how to differentiate between file types? You should be able to see with the ls-l. With the properties, you can see that. So generally for all directories, all folders, you see the first character would be D. D is nothing but a directory. Suppose we got some files over here. Let me just create some files here. I'll be creating multiple files with the extension called .txt. With the touch command, I'm creating multiple files over here. Again, if you run the same command, you can see for files, the first character would be empty. That means these are files, remaining all are directories. Remember, to differentiate between file and a directory, you can just check the first character, the first property, what we call mode of permissions. The first field is called mode of permissions. The second field is called number of links. And the third field is called user ownership. The fourth field is called group ownership. The fifth field is called the size of the file or a directory, always in bytes. That's mean it's almost like 4 KB. 4096 bytes is equal to 4 KB. Then the date and time stamp. At last you can see the directory name or file name. So in the first field, that is in the first bit, if it is D, that is directory. If it is nothing, it's a ASCII text file. If it is L, symbolic link files. If it is P, piped files, socket files, block special files, character special files, like that you should be able to identify. So everything, you work with hardware devices, you work with system information, you work with ASCII text files, you should be able to differentiate with the first character, the first bit in the first field. Or if you are very good at Linux, you should be able to run the command called file. I would like to find out what is exactly this file1.txt. You'll come to know, yes, it's a file.txt, it's an empty file. Same thing, if I run this particular command file desktop, now you can see this is exactly a directory. So desktop is not a file, desktop is a directory. File is nothing but collection of text, collection of records. A directory is nothing but group of files. Collection of files is called as a directory. So in Linux, everything is considered to be a file. Text files or directories or device files or system information, everything will be like a file. So this is what I was talking about. It can be a normal file, it can be a directory, it can be a symbolic link file. Symbolic link file. I think in Windows what we call shortcuts. Here we got some symbolic link files. Again in links also we have two types, hard link and symbolic link. Symbolic link sometimes also called as soft link. I'll tell you what is the importance of hard link and what is the importance of symbolic link. And then you have socket files. Socket files are generally used to pass information between your applications. How application would be able to access your data with the help of socket files. Like that, you have piped files, you have process character, hardware communication. Like that, you got many types of files in Linux. Character special files, block special files, socket files, piped files, symbolic link files. So with the help of first character, you should be able to identify that. I think better I would be able to switch on one of my Linux machine. Since I don't have super user access over there, I'll show you on my machine as well. And then you have a run level. Can you see all of you which is being highlighted over here? If it is nothing, that is a regular file. If it starts with D, that is called as a directory. If it is L, that is symbolic file, you see, which is linking to this original directory. So this is a link file which is pointing to original path, original directory. This is like a shortcut. So like that, you should be able to identify the different types of files. And then you have run levels. Like if I want to compare this run levels in Windows, like in Windows, we have normal mode. Windows, you can run in safe mode. I think you can run Windows in safe mode with networking option. Like that, you got different modes in Windows. So generally, when troubleshooting a Windows operating system, if Windows is not able to load, we have some problems with some bootloaders or we have some problems with disks. So generally we'll get into safe mode or we'll try to boot system, then we'll do some troubleshooting and then we'll bring back a system in normal mode. Like in Linux also, we have different run levels. As I told you, in real time, most of the Linux servers would be able to work in run level 3. In run level 3, you have a support for multi-user support. You have with network, but no GUI available. Generally, in real time, most of the Linux servers will be having the default run level as 3. They don't try to power on Linux servers in run level 5. In run level 5, we have the graphical support. What are the different run levels and how do you differentiate run levels here? So basically you have 7 different run levels starting from 0 to 6. 0 is to shut down the computer, is to halt the computer. 6 is to reboot the computer. We know run level 0, run level 6 is generally used for performing maintenance activities. How to reboot a Linux server, how to reboot, how to shut down the computer. You should be able to execute the commands like this. So if I go to my Linux box, if I execute the command shutdown -h now, my system will be halted. My system will be powered off. Same thing if I want to reboot my computer now, I can execute the command called shutdown -r now. -r is nothing but reboot. Like that, if you want to reboot, if you want to provide some grace period time, I would like to reboot my computer after 5 minutes. I can simply press over here and put 5. After 5 minutes, I should be able to reboot. So any command help you wanted, you simple execute the shutdown -h now. You see a lot of options are available. The way you would like to reboot, the way you would like to shut down, all that options are available. So in Linux, remember, generally there are 7 different run levels. When you're working on Linux, generally after you install, by default run level would be 5. You see, multi-user mode in GUI. In real time, you would see all Linux servers in run level 3. Multi-user support in CLI, but no graphics. Generally, you would be able to see Unix also, AIX, HPUX in this particular run level. Other run levels are, this is like troubleshooting mode. In Windows, we have safe mode. In Linux, we have a single user mode. This is for performing troubleshooting at the operating system level. This is multi-user mode with no networking file system. 4 is user defined, it is empty. If you wanted to bring up your own run level, the way you would like to start your Linux operating system, you can define here. This is run level 4 is by default empty. We don't have anything. So either you should be able to see in run level 3 or run level 5. So these are the different run levels, the way you would like to bring up your operating system, in which run level you wanted to bring up. That is all defined with the help of run levels over here. In the backend, all of you, some system initialization scripts will be executing. What services to be started, what services to be shut down, all that will be defined in these particular run levels. So generally, if I just take one real-time example here, if I go to single user mode, if I try to bring up my Linux system in single user mode, as I said, it's only to perform some troubleshooting techniques. Like in real time, you lost your root password or you forgot the root password and you don't know how to log in with the root password. So what exactly I need to do is I just need to power off. I need to bring up my system. I generally won't be starting my Linux system in run level 3 or run level 5. I would be starting in single user mode. There I can go, I can simply change the password again. I can log back in the default mode. Like in the later versions of Linux operating systems, like these run levels, the name has been changed to targets. Until 6, it was called run levels. From RHEL 6, RHEL 7, 8, these are called targets. That's the only difference. It's all the same in every distribution of Linux OS. And then comes on the pipes, all of you. This is one of the very, very important operators in Linux operating system. Like in the case if you want to work with multiple commands. Now, pipe operator you can use, like the output of first command will become the input for the second command. Let me show you practically here when I can use this particular operator. Now, I would like to find out the properties of my files and directories. In the case if you want to find only the names of files and directories, you simply execute ls command. See, with ls command, one cannot find out the differentiation between a file and directory. Yes, with the color coding you can do that. So generally, if it is regular, you see these are files. If it is blue color, you see these are folders. Like if you have a black and white monitor or you don't have colors enabled, so no one can differentiate between file and directory. On that case, what exactly you can do is you have an option called ls-l. In fact, every command has got a lot of options and every option will proceed with hyphen, and option must be executed within the space of the command. The command is ls. You have to give a space. Option must proceed with hyphen and then you have to specify the option here. This is the right way of executing command with options. And no one should execute something like this. This is a bad command. See, shell is giving you the error. What is this? I'm interacting with the operating system with the help of shell. This is one kind of user interface. If I want to find out the properties of files and directories, I have to execute the command ls, give a space -l. That's a right way of executing the command. There you can see with the first property over here, the first bit, if it starts with D, that is called as a directory. If it starts with nothing, that is called as a file. Like that, if you see the properties of bin directory here, you see starts with L. That means it's a symbolic link file. This is the original command and this is something like link command. L means symbolic link file. Like that, you have P, you have character special devices, block special devices. Like that, you have many file types in Linux. So I was talking about pipe. What is the operator pipe useful for us? If I execute ls-l, now I want to filter out something. I want to see only files. I don't want to see directories. Or I wanted to see those files starting with the extension txt. Or you can use a pipe operator. Like, what is the useful of pipe operator? Is the first command output will become the input for the second command. I want to put it in such a way that I was starting with the character hyphen. Now you can see I should be able to list only the files. So I'm using the command called grep. This is like a search pattern word filter. So what I'm trying to do with the grep command over here is I'm just grepping the first field of this particular property. Caret. This caret symbol always used for searching the patterns which begins. If I use dollar, that is end. Character means begins, dollar means end. In between the first and second command, the first command is ls and the second command is grep. In between the ls command and grep command, I'm using the operator called pipe. So what this pipe does is the output of the first command will become the input for the second command. So if I type ls-l, I can see everything. I don't want to see everything. I want to list only directories now. So what should I do there? Rather than specifying only hyphen, if I do D, I can see only directories now. Suppose you wanted to count how many directories are there. So I can use one more pipe operator here. I can just count the number of lines. That means totally I have 9 directories. The output of ls command is becoming the input for the second command. The output of second command is becoming the input for the last command. How I'm using the pipe operators between the first, second and last command. So like that, there are many operators available in Linux. Standard in, standard out, standard error. You have pipe operators. Got a lot of these things in Linux. See, this is what the output of the first command is becoming the input for the second command. One example, cat file.txt. In this file.txt, I'm searching for the word Linux with the word filter called grep. So this is all about some Linux concepts, files. Everything is considered to be a file in Linux and Unix operating system, be it application, be it device driver, be it a regular file, directory, everything is considered to be a file. Then you have run levels, the way you would like to bring up your Linux operating system. Run level 3, run level 5, or troubleshooting mode, or you would like to shut down, you would like to reboot. Run level plays a very important role. And these run levels, the name has been changed to targets in the recent versions of Linux distributions. Pipe is one such kind of operator which can be used to manipulate data or to check the desired output based on the requirements.